All right, today we're going to pull back the curtain on a really critical but, well, pretty much invisible piece of the internet, the reverse proxy. I mean, this thing is the unsung hero that makes so much of our digital world even possible. So let's just dive right in.
I mean, seriously, have you ever just stopped and wondered about this? You click play on a brand new show, and a million other people do it at the exact same moment? How does that website not just collapse under all that pressure? Well, the answer, or at least a really big part of it, is the technology we're about to get into.
Okay, so to really wrap our heads around this, let's start with a simple analogy. Let's not think about it as a piece of code for a minute, but as a person with a very, very important job.
So imagine you're walking into a huge office building. You don't just wander around trying to find the right office, do you? No way! You go to the receptionist, they check your request, they figure out exactly where you need to go, and then they direct you. And all the while, they're keeping the building secure and organized. That right there in a nutshell is a reverse proxy.
So here's the key takeaway. The reverse proxy is basically that receptionist, but for web traffic. It's a middleman that sits right in front of the actual web servers, and its job is to manage every single incoming request before it ever reaches its final destination.
And this really gets to the core of it. Just like you only ever talk to the receptionist, your browser only ever communicates with the reverse proxy. It never ever talks directly to the web server itself. And what this means is that the real identity and IP address of those servers are completely hidden. That adds a really powerful layer of security and flexibility.
Okay, so that's the what. But how does it actually work, step by step? Let's follow the journey of a single request you make on the internet and see what happens.
Okay, so you make a request. First, you connect to what you think is the website, but surprise, it's actually the reverse proxy. The proxy gets your request, and then it forwards it to the correct internal server. Then, that server finds what you want, a web page, a video, whatever, and it sends it back to the proxy. And finally, the proxy delivers that response to you. The best part is, the whole process is totally seamless. You never even know there was a middleman involved.
Now, this whole setup isn't just for show. It gives the reverse proxy some incredible abilities, superpowers, really, that are absolutely essential for the modern web. Let's break down what those are.
All right, these are the big ones. A reverse proxy can do load balancing to distribute traffic. It can provide enhanced security to shield servers from attacks. It can speed up performance by caching content. It can handle all the encryption and decryption, that's called SSL termination. It can compress data to make it faster. And it can even manage user logins from one central spot. Each of these is a huge deal.
So let's start with load balancing. This right here is the answer to our original question about Netflix and Amazon. See, instead of one massive server, they have thousands of them. The reverse proxy acts like a traffic cop, cleverly distributing all the incoming requests across this whole pool of servers, and that means no single one gets overwhelmed. This is exactly what keeps your favorite sites online during those huge traffic spikes.
And then you've got security. Because attackers can only see the reverse proxy, they can't directly target the actual web servers behind it. So, the proxy becomes a shield. It filters out malicious traffic, like those nasty DDoS attacks, where hackers try to overwhelm a site with fake requests before it can ever do any damage.
Okay, now this is where things can get a little confusing for people. You've probably heard of a proxy before, but that's usually what we call a forward proxy. So, what's the difference? Well, it all comes down to who the proxy is working for.
Okay, the difference is actually really simple when you break it down. A forward proxy, something like a VPN, sits in front of you, the user. Its job is to hide your identity. It protects the client. A reverse proxy, on the other hand, sits in front of the server. Its job is to hide the server's identity. It protects the server. So see, one protects the user, the other protects the website. It's really all about perspective.
To truly appreciate why reverse proxies became so incredibly important, we need to take a quick trip back in time to a major engineering crisis that really shaped the modern internet.
It was called the C10K problem. That's C for connections and 10K for 10,000. The challenge was simple on paper, but it was immense in practice. How could a single server possibly handle 10,000 simultaneous connections without just grinding to a complete halt? The old methods, they just weren't going to cut it.
So that number, 10,000, it became the benchmark. The race was officially on to find a new, much more efficient way to manage all this network traffic. The old model of having one thread per connection, well, it was just incredibly inefficient and ate up a ton of resources.
And here's the result of that race. This table says it all. It shows the time it takes to handle connections using an old method called poll versus a newer one called ePoll. Now just look at that 10,000 connection mark. The old way takes nearly a full second. The new way? Less than 1 millisecond. That is a revolutionary jump in efficiency. This new approach, known as non-blocking I/O, which is basically a way to handle many tasks at once without waiting around, is the engine that powers modern reverse proxies and solved the C10K problem for good.
So, let's bring it all together. When you think about it, we went from a simple receptionist analogy all the way to a high-performance traffic manager. The reverse proxy truly is a cornerstone of the modern web.
It really is the invisible force that ensures reliability, security, and speed every single time you go online. Without it, the internet as we know it, scalable, resilient, and fast, it just simply wouldn't exist.
And this isn't just some abstract concept, right? It's powered by real, powerful software that millions of websites depend on every single day. We're talking about tools like Nginx, which powers a massive chunk of the web, or Proxy, which is famous for its high-performance load balancing. You've also got Apache, Traffic, Envoy. These are the titans of this space.
So, the next time you browse a website and everything just works perfectly, you'll know about the unsung hero working behind the scenes. And that leaves us with a final thought. What other hidden technologies do you think are out there, quietly holding our digital world together every day? Thanks for watching.